Hi, everybody. Today we are going to be discussing matter. So we have a lot of reasons that we talk about matter in chemistry and in science in general. And so the different classifications of matter, as we can kind of break them down further and further, will lead us into an understanding of atoms, elements, molecules, compounds, things like that. So today we're going to start very generally. Again, we're still reviewing some stuff that we learned last year in baby chem. So the definition of matter is anything that has mass and takes up space. And remember, taking up space is the same thing as saying that it has a volume. We have three main states of matter and then one that is also a state of matter, but we don't use it as much in chemistry. The first is solid. So a solid is rigid. It has a fixed volume and a fixed shape. So whatever container you put it in, it stays the same no matter what. When we look at the particles of a solid, we can see that they are close together, tightly packed. They stay in this orderly form, and these little lines mean that they are kind of like rotating, vibrating, moving a little bit, but they're not moving around the container. They're just kind of shaking in place. A liquid, on the other hand, has its own volume. It's definite, it doesn't change, but the shape can change. Whatever the container shape is the shape that the liquid takes. And so when we look at the particles for a liquid, we can see there's two lines on them now, so they're moving a little bit more. They're not rigid. They're not staying in one definite block. These are able to move around and kind of fill this container however they want. However, the volume, the total amount of space that they take up will stay the same. The third state of matter is gas. There is no definite volume or shape for a gas. Whatever your container is, the gas will take the volume and shape of the container. And the particles in a gas are much more spread out than they are in a liquid or a solid. They're also moving a lot more and a lot more quickly. And so the gas particles will be anywhere in this container, but the gas will just fill that container completely. And those particles will be moving a lot with a high speed. The fourth state of matter is plasma. We don't use it a ton in chemistry because it's not something that we really experiment with, especially in high school chemistry. Plasma is basically a superheated gas. And so when you have that gas that has those particles have a lot of energy, they're moving around, it can become ionized. And so having those positive and negative charges gives it some unique properties. This is actually the most common state of matter, but that's because it's in stars. And so all the stars in the universe have plasma in them. And so you wind up with that being like the most abundant. However, on Earth, plasma is less common. So here's just kind of a summary. You've got your solid where the atoms or the particles are in these like fixed, rigid shapes. You've got your liquid where they can move around, but they're still pretty close together. Your gas where they're spread out and moving quickly. And your plasma where they're also spread out, moving quickly, but now they have positive or negative charges. And to go from one to the other, you just add heat. So starting at the solid, if you keep adding heat, it will go through all of these different states until it reaches a plasma. We can classify matter as pure substances or mixtures. That is one of the most common ways to break down the types of matter. So we'll discuss the differences between those two and the different subcategories that are in both of those classifications. So for a pure substance, every pure substance will have a constant composition, meaning that If we could zoom in, all of the particles in that pure substance would be identical. They may all be atoms of the same type, or they may all be compounds of the same type, like molecules, but they would be identical. We also cannot separate a pure substance using a physical change. So we can't just filter out different pieces of it, or we can't just, evaporate part of it off and leave another part behind. It cannot be separated that way. The two types of pure substances are elements and compounds. Elements cannot be broken down into simpler substances by physical or chemical changes. We have to use special things like a nuclear reaction to break down an element. So nothing that we would be able to do in a chemistry lab could break down an element. Compounds, on the other hand, can be broken down into simpler substances by using chemical processes. So we can use a chemical reaction to break down a compound. However, we still cannot use any type of physical change to break that into its simpler components. Okay, when we have a mixture, there is a variable combination of pure substances. It may or may not be the same ratio or the same throughout. So the amount of one substance in a mixture might be more than the other. So the mixture is different from the pure substance in that we separate a mixture using a physical change like filtration or evaporation, for example. There's two types of mixtures, homogeneous mixtures and heterogeneous. In a homogeneous mixture, you cannot see the different parts. So it looks the same throughout. If you were to take a sample from one part of the container and a sample from another part of the container, they would look exactly the same. For a heterogeneous mixture, you can see the different parts. And so if you took a sample from one part of the container versus another, they may not look exactly the same. And you would be able to see the different components. You may not be able to see all of the components, but you would be able to see most of them. So this chart just kind of breaks down matter into the different categories. So we have pure substances and mixtures. As we said, mixtures can be homogeneous or heterogeneous, and we can take that mixture and turn it into its pure substances using a physical change like filtration, for example. We can then take those pure substances and we can see if they're elements or compounds. Those are our two types of pure substances. And a compound can be broken down into elements using a chemical reaction. However, an element cannot be broken down any further. So we keep talking about physical and chemical changes used to separate a mixture or a compound into elements. So we talked about these a lot last year too. So physical changes take advantage of the physical properties of a substance, like the boiling point or the state of matter, like whether it's a solid, liquid, or gas. So a physical change tends to be a change in the state or the form of a substance, but not in its chemical composition. So the particles retain their identity when a physical change happens. For example, if we boil a substance and it goes from a liquid to a gas, that substance at the particle level is still exactly the same. It has just changed form from a liquid to a gas. Those particles now have more energy. But the particles themselves have not changed at all. So some examples, like tearing paper, breaking glass, anytime you're doing something like that, you're not actually changing it. The paper particles are still paper. It's just in a different shape now, right? Most of the time when you mix two things together as well, as long as the chemical reaction doesn't occur, that is also a physical change. So mixing cereal and milk, if you mix sugar into tea, those are all physical changes because they're not changing the identity of the substance. So physical changes are used to separate mixtures into pure substances. But again, we cannot use this to separate compounds into elements. Only mixtures can be separated with a physical change. There's several types of physical changes that we use in chemistry. This first one is distillation. We don't have the setup to do this at school, but if you take chemistry, especially organic chemistry in college, you will get to do a lot of distillation. So distillation is based on the boiling point of two or more liquids that are mixed together. Most liquids have their own unique boiling point. And so, for example, we have this hot plate and we put our mixture on top of it. And that we heat up until one of our liquids in that mixture starts to boil. And remember, when it boils, it changes from a liquid to a gas. So the gas rises, and we filter it down this tube. Usually there's a cap at the top of this, so it can't just come out. And then we have this condenser on the outside of that tube that runs cool water around the tube. It doesn't mix with the gas. It just cools it off so that it changes from a gas back into a liquid. And it's sloped downwards so that that liquid pours into this new container where we can collect it. And once that substance has boiled all the way off and we've collected it all, we can replace this flask with a new one for when the next substance starts to boil, and so on until they have all boiled off. And so this just depends on the boiling points of the substances. So it's a really handy way to separate two liquids. One physical change that we use a lot in chemistry is filtration. Filtration is mostly used to separate a solid from a liquid, and we use a filter paper. Sometimes we use gravity filtration, which is like what this one is showing. Basically, it just uses gravity to pull the water down, kind of like a coffee maker, right? So the liquid can go through the filter paper and the solid stays in the paper, in the filter, and you get both of them separate. Sometimes we'll use a vacuum filter, and I'll show you how to do that when we get to that part, but that just speeds up the process so that we can filter things out a little faster. Chromatography is another physical change that we'll use in chemistry this year to separate mixtures. In chromatography, we have a piece of filter paper, and we call that the stationary phase. In this case, stationary means it stays put, it stays still. And then there's a liquid, which we call the mobile phase. So we put a sample of our mixture on near the bottom of the paper. And then we stick that paper into a beaker with a little bit of liquid in it. And that liquid will crawl up the paper. It moves up the paper. It's just what liquids tend to do. And that mixture will move with it. However, not all of the parts of the mixture will flow at the same rate. Some of them will be more attracted to the paper, and some of them will be more attracted to the liquid. And so the ones that are more attracted to the paper will stop first. So you can see in this first filter paper here that the red dye stopped first, which means it was more attracted to the paper. The blue dye traveled the furthest, which means it was more attracted to the liquid. The other type of change that we can experience in chemistry is a chemical change. We often call this a chemical reaction. In this case, a substance will become a new substance. It'll have different chemical and physical properties, and it will also have a different composition at the particle level. We can't destroy or create atoms. So really, when we're talking about a chemical change, we're looking at atoms combining in different ways. So they may be breaking apart from one another or combining with each other, but the atoms themselves still retain their identity. It's just the compounds that will change. So some examples of chemical changes are anytime you burn something, burning wood, gasoline, paper, that is a chemical change because those things are changed into totally new substances. Cooking and baking tend to be chemical changes as well. And you can kind of think about a chemical change in a lot of ways. It's something you can't change back easily. So like if you bake a cake, you can't take that cake and turn it back into flour and eggs and sugar. It is just a cake now. Another example is when you mix baking soda and vinegar together. You guys have probably done this at maybe in elementary school and you get all the bubbles and stuff. So that's an example of a chemical change because those are actually reacting when we mix them. Unlike the mixtures we talked about with physical changes, which are not reacting, they're not forming new substances. So a chemical change is used to separate compounds into elements, or it could also be used to do the opposite, to combine those elements into compounds. So this is kind of just an overview of matter. As we go through the semester, we will get more into depth on what's happening at the atomic level in these chemical changes specifically. And we'll talk about, chemical reactions and balancing equations and all that stuff. But yeah, make sure you know the difference between pure substances and mixtures and chemical changes versus physical changes.